Hi, thank you for clicking this video. This is Mieowkee from Center for Water Research at Sagi University. I would like to share with you the finding of the preliminary study for ammonia removal using activated rice husk. In this video, we will focus only on kinetic study. Ammonia pollution due to the excess use of fertilizer in agriculture activity and livestock farming causes eutrophication and algae bloom, which eventually disrupt the marine ecosystem equilibrium. Efforts have been made to either recover or remove ammonia from water. To date, absorption is widely used to remedy water resources as it is cost and energy effective. Rice husk is one of the popular absorbents due to its availability and low cost. In absorption, kinetic study is adopted to evaluate the absorptive performance of absorbents and investigate the mass transfer mechanism. This provides insight to the engineers on the possible method to improve the absorption process. Thermal and chemical treatment, especially acid treatment, are commonly used to enhance the absorptive capacity of rice husk. Study on alkaline-treated rice husk is very limited. As per presented in the slide earlier, absorption kinetic models are important in evaluating the performance of absorbent and reveal the absorption mass transfer mechanism. Nevertheless, the kinetic models reported in the literature was not comprehensive as only a few models were considered. Meanwhile, the statistical parameter to validate the model was commonly depends on R-square value alone. Thus, this is difficult to justify if there is more than one model shows more than 0.99 R-square value. Thus, the objective of this study is to provide a comprehensive kinetic study of ammonia absorption using alkaline activated rice husk to the reader by investigating the validity of 9 kinetic models in fitting the experimental data. All the models are validated by using R-square, chi-square, residual sum of square, and mean square error. In this study, activated rice husk were prepared by soaking the charred rice husk in 1 molar of sodium hydroxide for 24 hours. Then, the rice husk was dispersed into ammonia solutions and stirred at 150 rpm. The sample was collected to measure the ammonia concentration. This figure describes the theoretical and experimental absorption capacity of activated rice husk for ammonia removal at different time intervals. The experiment data shows that the equilibrium capacity of activated rice husk is approximately 3.8 mg per gram. This is comparable with the recent study done by Khalil, where the capacity of the activated biochar was within 2.9 to 4.5 mg ammonia per gram at temperature between 25 to 45 degrees C. This is notable that the majority of the predicted absorption capacity shown in this figure are very close to the experimental data, except for the result predicted from Matthew and Wilbur and Morris model. These indicate that external and internal diffusion contribute minimal impact to this absorption process. Generally, the absorption data fit the empirical model, such as pseudo first order, pseudo second order, mixed order, pseudo n order, and Elowish model very well, where R-square value more than 0.99 is observed. Thus, it is difficult to justify which model predict the data the best based on R-square value alone. From the statistical data shows in the table below, mixed model shows the lowest SSE, chi-square, and MSE value. This indicates that mixed model is the best model to fit the ammonia absorption data in this case. This is because mixed model combines pseudo first order and pseudo second order, which are good in predicting the initial and final stage of absorption process. High R-square value and low SSE, chi-square, and MSE for both Ritchie and Elowish models suggest that the absorption at active site was the rate limiting step in this absorption process, and it was driven by chemisorptions. So as conclusion, activated rice husk produced in this study removed ammonia by absorption, and the equivalent absorptive capacity was 3.8 mg per gram. Mixed model describe the absorption process very well with R square value more than 0.99 and low SSE, chi-square and MSE value. Besides, more than 0.99 value with low SSE, MSE and chi-square value were also observed in Ilowich and Richet model, which confirmed that the absorption at active site was the rate limiting step in this absorption process and it was driven by chemisorptions. It is recommended to modify the surface of the absorbent to increase the number of active sites to further enhance the absorption process. This is the list of references cited in this work. I believe one of the objectives of conference is to gather the researcher and look for the opportunity to do collaboration with the intention to bring our research to the next level. However, due to the COVID pandemic, we couldn't meet each other for discussion. Therefore, before I end the presentation, I would like to take the opportunity to inform you that we are looking for potential collaborators to work in the form of matching grant on water and bioprocess related research. This is my contact and please feel free to drop me an email or give me a call if you would like to have a collaboration with us. Thank you very much.